Hello everyone, my name is Lara Blazevic and I'm a first-year PhD student within the Enigma ITN, and I work in Sorbonne University in Paris. So the title of my research is Monitoring Spatio-temporal Water Redistribution with Seismic Methods, and the idea behind it is that the seismic methods give us information about how waves propagate in a given medium. So when we have a seismic acquisition, we get something like this. So for a given shot, we can recognize the P wave refraction and also the surface waves over here. Why are they useful? Because the P wave refraction is going to give us information about the VP, the P wave velocity of the medium, and the surface waves, doing surface wave dispersion analysis, can give us information about the S wave, which is the shear wave velocity, and together they can be used to monitor how the water saturation is changing in our medium. So how do we do this? VP and VS are partially decoupled and they respond differently to fluid saturations. So in this synthetic example, I show how water saturation is changing in a given table with depth. And in this second plot, I'm showing how VP responds to the change in water saturation and how VS responds to these changes. So using VP-VS ratio, we can see that we can discriminate between the zones where we are dry or unsaturated and the zone where we are fully saturated. So this is useful to discriminate our water content in a given underground site. So I show a field case from a site here in France, in Brittany. So the site is Plumard, and it's a contact zone between granite and mica schist, and we have a seismic profile perpendicular to the contact zone. So there were some time-lapse data acquisition, and we got a data set from October. So at the top we have VP, and at the bottom we have VS. And we have the same data, but for May of 2012. So using a rock physics model that allows us to relate VP and VS to water saturation, we can invert for the water saturation that we're looking after. And we get something like this. At this moment in time, I observe the changes in the data, but during this inversion process with the rock physics model, I'm not really sure if we can see these changes in the inverted parameters. So my next steps are going to be to test different rock physics relationships that might translate the data changes to saturation variations. Thank you very much.